Helia.
And I'm Phoebe.
We are from Christians Alliance at Seacham Memorial College, and our experiment is bubble tea, and it's designed for children from 10 to 12 years old.
So first of all, let us introduce ourselves. I'm Phoebe, as I just said. I'm a Form 5 student. I study chemistry and biology, and I love food science.
And I'm Helia, and I'm also a Form 5 student. I study chemistry, biology, and physics, and I love doing experiments.
So Helia, do you like drinking Taiwanese drinks?
Yes, especially for the bubble tea and the popping bobber, the little just bowl with a liquid center. But do you think that we have any maybe method to combine these two things together? Having a huge popping bobber mixed up for bubble tea?
Well, actually, yes, by the means of molecular gastronomy, which is using chemical methods to change the form of presentation of food, we can actually make liquid drinks into solid bubbles, for example. And actually, you can eat bubble tea in the form of an actual bubble. Other examples of molecular gastronomy would be changing carrots into salmon roe. So now let us play a clip so you can see how it works. So what do you think?
Oh, it looks fun, but it's still an experiment so that we have something you should remember to keep yourself safe. First, use slow power heating for warming the solution. Second, heat your solution with the guidance of adults. Third, stir the solution gently and avoid splashing out. Finally, prevent the solution getting into your eyes, so we will suggest you to wear goggles.
So now let's have a look back at our ingredients. First of all, of course, we have water. Then we have sodium alginate. It is a type of natural polysaccharide, so its structure is quite similar to sugar. And you can also treat it as a type of polymer. It is usually used in food as a food additive. You can find it in cosmetics and in medicine as well. Then we also use calcium lactate. It is normally found as a kind of calcium supplement. For example, you can find it in pills for preventing osteoporosis. Finally, we have your drink of choice. So now here are some things to note when doing the experiment. When you're dissolving the sodium alginate, you can choose to heat the solution in order to dissolve the alginate quicker. However, if you want it to taste better, we would suggest using cold water instead. Since we want to save time in our experiment, we decided to heat the solution.
And in the video, we mix the sodium alginate solution with the drink in 1:1 ratio. But in this method, the drink will be diluted. And if you don't want your drink to be diluted, you can directly dissolve the sodium alginate using the drink. But be careful to the ratio of sodium alginate and the drink if you use this method.
Then we suggested dipping your spoon into the calcium lactate bath first. This is done since when you pour the drink mixture into the spoon, it will form a jelly-like layer beforehand, a thin layer first. So when you put the bubble into the calcium lactate bath and form the full bubble, it will look prettier when you get the finished product.
And if you leave the bubbles in the calcium lactate bath for a longer time, the jelly layer will be thicker. So if you don't want your bubble to burst so easily, just leave it in the calcium lactate bath for a longer time.
So after all these complex procedures, I think we all have some questions. First of all, why will a drink become a bubble?
It's due to the reaction between the sodium arginate and the calcium lactate. When the sodium arginate is dissolved, it is loosely packed in water. Like you can see in the picture on the left. They are separated and can move freely. It's like children moving freely and playing in the playgrounds during recess. And in the calcium lactate solution, the calcium lactate ionizes to give calcium ions for the reaction. And when the sodium arginate solution is added to the calcium lactate solution, the calcium lactate will cross-link with the arginate. As you can see in the picture in the middle, the calcium ions link up the sodium arginate and form a network. It's like the teacher telling the children to line up and hold their hands. And they will form a network. And as the sodium arginate is packed uniformly and have a network, the solubility will decrease and the calcium arginate gel-like layer will be formed. As you can see in the picture on the right, there is a layer around the bubble. And you may also ask that what are the differences if we add the two solutions reversely?
So first of all, both methods would work. The method we use is called direct spherification. You will get a bubble with a gel-like center. However, the other way around is called reverse spherification. It is most commonly used in commercial practice, meaning when you go to restaurants and you order a molecular gastronomy drink bubble, it is most likely produced using this method. Using reverse spherification will give you a bubble with a liquid center. However, if you use this method, you will need to freeze the drink mixture beforehand, and you will need to put the frozen drink mixture into a heated sodium alginate bath. Although it's more complex, you will actually get a drink bubble with better taste and texture, since the center is still a liquid, and the bubble can be kept for a longer time, meaning that the center will not turn to jelly as well, unlike indirect spherification. So, this is a fun experiment. Would you like to tell others how we created it?
At first, our main idea is to design a special experiment for the kids, because in the internet we already can find many information about science experiments that kids can do at home. So that we would like to give them some special experiments and something they can play with to grab their attention, and also let them to understand that chemistry is fun, and it's not a very complicated knowledge.
So we thought of things that children may like, and actually children, for example Helia right next to me, love bubble tea, especially people nowadays. And also bubbles are a fun pastime in my childhood. I love playing with bubbles. So we decided maybe we should make the bubble in bubble tea a reality, and make bubble tea as just this huge bubble so people can have fun while eating it. And it will be a nicer presentation, maybe something more new. Then, after some research, we also discovered reverse spherification, which is used in molecular gastronomy. We tried to create it, but we realized that it needs freezing and it takes more time, so we decided to use direct spherification for our presentation this time.
And you may have some questions, or maybe the children will have some questions about the experiments. Like, what if we use a different concentrations of sodium arginate and calcium lactate?
Another question children may ask is, what will happen if we add carbonated drinks instead, since children also like soft drinks?
And more as the children can think of.
So this experiment is fun, it's edible, we think children will have fun making it, you can make it into different fun shapes, so we hope children and, of course, everyone here will enjoy it. Thank you.
Thank you, Helia and Phoebe. And now we have 5-minute Q&A section.
Thanks. Just the last one, we heard the two girls using calcium chloride, and you're using calcium lactate. So, are these two replaceable?
Well, in theory, it's replaceable since we need the calcium ion, and the chloride or the lactate is not really that important. However, when considering we're going to eat the bubble, calcium chloride is a less desirable a less desirable element, since calcium chloride is usually used as a drying agent, less commonly used in food, and calcium chloride will actually give an acidic solution, which is something we do not want when we're making the bubble, since it will prevent the cross-linking of calcium ions and the alginate. On the other hand, calcium lactate is more commonly used in molecular gastronomy. In fact, when we bought it from a shop selling stuff related to molecular gastronomy. So we think it would be a more suitable alternative compared to calcium chloride.
Also, if you use calcium chloride, it will give a bitter taste. So, but if we use calcium lactate, it will taste better and won't have the bitter taste. So we use the calcium lactate.
Maybe a question, bubble tea I know is very popular in Asia, but I think in other parts of the world it's not that famous, or people even don't know what bubble tea is all about. And thinking about that Kids Lab is a global program, and this might turn into an experiment which we could use in other parts of the world. Have you thought about using the same idea, but either giving it another name or producing those bubbles into something else? Putting it into an alternative drink?
Of course, we can change the drink. Maybe we can let the children to choose the drink they would like and use it in the experiments.
Or maybe if, for example, most children like juice, of course, especially orange juice, and maybe we can change the name to something like Fruit Pebbles. It's basically the same concept, just a different type of name, different kind of packaging.
Is there any kind of drink where you would not recommend to put the bubbles in? I mean, aside of alcohol, but just saying from...
Well, first of all, alcohol is doable for adults, of course not for children. And we consider the carbonated drinks. There's quite a large possibility that actually the bubble will burst due to the carbon dioxide. So we would not recommend it. Also, carbon dioxide is more acidic, so it may not actually work. So also, we would not recommend using carbonated drinks.
Thank you very much. When compared to the previous group on using calcium chloride, use calcium lactate, are there any, one thing that is, do you think there are any rate of reaction differences in between these two reagents reacting with the sodium alginate?
I think there is no very big difference, because the reaction is due to the calcium ions, and when we dissolve the calcium chloride in the water, it gives the calcium ions for the reaction. Therefore, it won't have many difference in the reaction rate.
Hello, have you ever tasted pure sodium alginate?
Actually, we did.
And what did it taste?
Well, it does not really have much, like you can't really describe the difference. It's just a bit more like eating gel, honestly.
Is it salty at all?
I don't recall tasting salty stuff in it.
Okay, thanks.
Thank you for all your questions.
Thank you, Helia.